derivation of the double-slit formula, sometimes referred to as Young's double-slit formula. You got two sources of light going through the double slits. It's slits 1, slits 2. These two lights has to be coherent, meaning that the frequency of these two lights are the same, the wavelength are the same, and its phase difference is constant. When the light strikes the screen, you will get constructive, destructive, constructive, destructive, constructive, destructive interference. The constructive interference are called the bright fringe, and the destructive interference are called dark fringe. The first constructive interference is when the light comes from there and hits that, and comes from there and it hits that. And this is when n equal to 0, because there's no path difference between these two. As you can see, if we go from there to there and from there to there, the path difference is 0. So therefore, n equal to 0, and you're going to get zero path difference. A path difference for constructive interference is n lambda. The path difference for destructive interference is open bracket n plus a half close bracket lambda. So now let's go for this the second, or if you like, that's the first fringe, and there's the second fringe. So let's go for the first fringe, the first fringe here, which is you got a light coming from there to there, and another one coming from there to there, and the path difference, you see, is n lambda when n is 1, so it's just going to be lambda. So the distance between that and that is lambda, because we come from there to there. If I go from there to there, it will sustain an angle theta, which means I'll go from there to there. And that angle is also theta, because I'm going from there to there. This line is going from there to there, while this is fixed, and that's fixed, which means I'll go from there to there. So because I've done 1n, you can see, put 1 here, that's just be lambda. So the path difference is lambda. If I go from here to there, that's 2n. You can see, I'll draw the line from there to there, and that to there, and the path difference will be 2 lambda, because that'll be 2n. So that'll be 2 lambda. So these are a few definitions, like the fringe spacing. This is measure of fringe spacing. That's the difference between constructive and adjacent constructive, or destructive and adjacent destructive. Fringe spacing, the distance between two adjacent maxima, and as a constructive is a maxima and a destructive is a minima, or two adjacent minima. So now let's derive the Young's double-slit formula. First of all, we're going to use, you can see a right angle triangle here and a right angle triangle there. So therefore, we're going to use SOHCAHTOA. SOHCAHTOA. We can apply SOHCAHTOA or Pythagoras to right angle triangle. This is sine of an angle theta equals opposite over hypotenuse. Cosine of an angle theta equals adjacent over hypotenuse. Tangent of an angle theta equals opposite over adjacent. We've got right angle triangle here. The hypotenuse is always opposite 90 degrees. This is 90 degrees. So the hypotenuse is going to be that. So that will be the h, hypotenuse. And for this angle, the opposite is going to be this one. So you can see the hypotenuse is always opposite. The hypotenuse is always opposite 90 degrees. This one is 90 degrees. The hypotenuse will be that. So that will be h. For this one, this is the opposite of that. So this is O, the opposite. And this bit here will be the adjacent. Likewise, this is the hypotenuse, that's the opposite, and that's the adjacent. So we can now choose which one to use. If we look at this first triangle, right angle triangle, you can see we've got the hypotenuse, which is S, and we've got lambda, which is the opposite. So we've got opposite and hypotenuse. What has opposite and hypotenuse here is going to be sine. So we're going to use sine for this one. So we can say sine of an angle theta is opposite O over hypotenuse. So we can then say the opposite is going to be what? The opposite of this angle is lambda, and the hypotenuse is going to be S. And that's sine of an angle theta here. What about for this one? Well, what can we use? We've got the opposite, which is W, and we've got the adjacent. We haven't got the hypotenuse. We've got the adjacent, which is D. The distance from there to there is the same as that because this is parallel to that. So this distance is D. So we got that D. So we got the adjacent and we got the opposite. Because this angle, the adjacent, is this one. Adjacent means next to the angle. And the opposite is W. So what can we use that has opposite and adjacent? It's going to be TOA. T stands for tangent, so that will be tan of an angle theta is opposite over adjacent, which meant that tan of an angle theta will be the opposite of that is W, and the adjacent is D. So that's adjacent here, that length from there to there. So that's D. Now, looking at for sine theta, it's just, is we said, is lambda over S from there, which is opposite for this one. Opposite, which is the lambda, and hypotenuse is S. This length here is S. And tan theta is this one here is going to be opposite over adjacent. This length here is adjacent, that's D. So that will be W over D. So for a small angle, sine theta will be approximately equal to theta, and tan theta will be approximately equal to theta. So what that meant is this will be equal to theta, and that too will be also equal to theta. So that will be, so therefore lambda over S is equal to theta. W over D is also equal to theta. Since they're both equal to theta, lambda over S will be equal to W over D. And if I make W the subject, so that means I want to make W the subject, so that will become W equals, multiply both sides by D, so you get lambda D over S. And that is the double slit formula. So the double slit formula is W, the fringe spacing, is equal to lambda times D over S.